In the video on reduction formula 4, we talked about the integral of cos nx dx, and it is equal to, if this is I sub n, it is equal to 1 over n into cos n minus 1 x sine x plus n minus 1 divided by n into I sub n minus 2. Alright? And in the video on reduction formula 5, we talked about the integral of sine n to the x dx. So if this is I sub n, we deduce the reduction formula that is equal to minus 1 over n sine to the n minus 1 x cos x plus n minus 1 over n into I sub n minus 2. There is a special case, or there is a special reduction formula if we take the limit of integration of these two integrals from 0 to pi over 2. And that is what we call the Wallis formula. So let I sub n be equal to, let me make use of the first one. Anyone I make use of, I will still get the same result. Is either I use the integral from 0 to pi over 2 of cos nx dx, or I use the integral from 0 to pi over 2 of sine nx dx. Both of them will produce the same result. Okay? Now, it means that I'll be taking this from 0 to pi over 2. That is, I'll take this, just this, leave this alone. 1 over n cos n minus 1 x sine x from 0 to pi over 2 plus n minus 1 over n into I sub n minus 2. Right, that's what I'm doing. So this will give me 1 over n into cos n minus 1. Let's plug in the upper limit. Pi over 2 is 90 degrees. So we have cos pi over 2, which is cos 90 degrees, times sine pi over 2. Then we subtract, plug in the lower limit now. So we have 1 over n cos n minus 1 of 0 sine 0 plus n minus 1 over n into I sub n minus 2. Everything here will give us 0. Everything here will give us 0. Sine 0 is 0. Everything becomes 0. Cos 90 degrees is 0. Everything becomes 0. So we are just left with over n into I sub n minus 2. So this is I sub n. This is what we call the Wallis formula. Okay, I told you if I perform the integral of sine nx from 0 to pi over 2, I will still get this. So I want to leave it for you to verify. Okay, n minus 1 over n I sub n minus 2. So n1 is the same thing. So we call this the Wallis formula. On this note, let's take two problems, one for each of these integrals. So using this reduction formula, which is the Wallis formula, let's evaluate the integral of cos x all to the power of 7 dx from x equal to 0 to x equal to pi over 2, and the integral of sine x all to the power of 5 dx from x equal to 0 to x equal to pi over 2, using this Wallis formula. Now, for the first one, it will be I7 because n is 7 here. Okay, so the integral of 0 from 0 to pi over 2 of cos 7x dx. So here n is 7. 7 minus 1 is 6. That will be I5, right? So what's I5? I5, we can easily do that here. is the integral of from 0 to pi over 2 of cos 5x dx. That's simple. 5 minus, okay, 5 minus 1 is 4 over 5 I3. So we have 4 over 5 I3 was I3. The integral from 0 to pi over 2 of cos 3x, or that's cos cube x dx, will be, if you check, 3 minus 1 is 2 over 3 I1. So you have 2 over 3 I1. And lastly, will be I1. That's the integral from 0 to pi over 2 cos x all to the power of 1 because it's 1. That's cos x dx. If you integrate cos x, the integral of cos x, let's proceed from here, is equal to sine x. Yeah, integrate the cosine function to get sine. So we have sine x from 0 to pi over 2. So plug in the upper limits. That's sine pi over 2, then minus plug in the lower limits, sine 0. Sine 90 degrees is 1. Sine 0 is 0. So all we have is 1. So that's I1. Therefore, I7, which is the integral of cos x all to the power of 7 dx from 0 to pi over 2, is equal to, let's come from here now, 6 over 7 I5. What's I5? Everything here. That is 24 over 35 I3. What's I3? This I3 here. 2 over 3 I1. That's times 2 over 3. Okay, in place of I1, I'll just write 1. Right? I'll just write 1. So 3 here is 1, 3 here is 8. 3 times 8 is 24. So 8 times 2, that's 16, times 1, 16 over 35. So this is the value of that integral. In the same vein, let us attempt the second one. The integral of sine x all to the power of 5, that's sine 5x dx, from x equal to 0 to pi over 2. Okay, let's call this I5 because n is equal to 5. So using the same Wallis formula, we have a 5 minus 1, that will be a 4. So 4 over 5 I3. Right? I3 is the integral from 0 to pi over 2 of sine cube x dx. And using the same reduction formula, it will be 3 minus 1. Yeah, 3 minus 1 is 2. 2 over 3 I1 because 3 minus 2 is 1. So we have 2 over 3 I1. What's I1? So the power of n here is of sine x is 1. That's sine x dx. Integrate sine x to get minus cosine. That's minus cos x. Remember, the integral of cos x is sine x, but the integral of sine x is minus cos x from 0 to pi over 2. So plug in pi over 2 first, so we have minus cos pi over 2 minus, plug in 0, minus, get a point now. This one is 1, and cos 0. Cos 90, which is pi over 2, is 0. So what we have here is 0. Minus cos 0 is 1. And this will give me positive 1. That means I1 is equal to 1. i's are 5, which is the integral of sine 5x dx from 0 to pi over 2 is now 4 over 5 times I3. What's I3? I3 is 2 over 3 times I1. What's I1? I1 is 1, right? You get it? 4 times 2 times 1 is 8. 5 times 3 is 15. That's it. So this is the deduction and the application of the Wallis formula. The reduction formula for the integral of sine nx dx, this is dx, from 0 to pi over 2, and the integral of cos nx ds from 0 to pi over 2. Alright, keep watching, see you in the next video. Subscribe, like, and share this video to your friends and your classmates.